Today we're going to talk adding and subtracting polynomials, and the math we're going to do today is not that difficult. It's just there's a lot of vocabulary, and we're going to use this vocabulary quite a bit during the remainder of the year, so it's best that you know it. First of all, we're going to talk what a polynomial is, and a polynomial is basically a monomial or a sum of monomials where each monomial is a term of that polynomial. Now, we've talked about monomials before. They usually have some form of a constant, some variable, or product of variables, and possibly exponents, something like that. So again, constant, two variables. A binomial is just the sum of two monomials. Trinomial, sum of three monomials. There's something called a degree of a monomial. Okay, and a degree is the sum of all its exponents of the variables. So in this case, my two variables were x and y, and I have exponents of 1 and 5, so this has a degree of 6. And the degree of a polynomial, so if I have a long term, the degree is just the greatest degree of any of the monomial terms. All right? And a constant, like the number 6, has a degree of 0. So there is no, well, we could say actually that it has a variable of x, but its power is 0. We know anything to the 0 power is 1, so it doesn't appear. All right, and we name polynomials in the following manner. If we have a degree of 0, it's called a constant. Degree of 1, it's called a linear polynomial. In other words, like 3x plus 7, that has a degree of 1. So that's a linear problem. Quadratic is a degree of 2. Cubic, degree of 3. Quartic, degree of 4. Quintic, degree of 5, and so on and so on and so forth. So now we're going to identify some of these things. We want to take a look at all the powers in each monomial term. So in this first problem, I have a variable of 1, no power written, so it's an unwritten power of 1. And therefore, yes, this is a polynomial term. And is it a monomial, binomial, or trinomial? There's two monomial terms in this, so this is a binomial. If we look at this term, let's just write the degree in here too. Kicks. In this term, we have 3 individual monomial terms. So this is a polynomial. We have a trinomial here because we have 3, and its degree is the greatest set of exponents, sum of exponents in any of the terms. Well, each of these terms has a exponent of 1, so this has a degree of 2, this has a degree of 2. So polynomial has a degree of 2. In this case, we notice we have a 5 d to the 4th in the denominator, right? And what that's going to do is it's going to create a negative exponent, so this is not a polynomial. And then that just rules all this out. And finally, we have 26b squared. That's a monomial term because it's only 1, and it is a polynomial. Let's continue to move forward. I want to find the degree of this polynomial. So the degree is the sum of the greatest individual monomial terms of exponents. Let's throw 1's in where we have no identifiable power. So this has a 4th degree, 3rd degree, 5th degree, and this is 0 degree. So the biggest sum of polynomial exponents is 5. So this is a 5th degree polynomial. Next, we want to identify which is a cubic equation, which has 3 monomial terms. This has 2. That's got 3. That seems to have 3. That seems to have 3. So we want to find a cubic polynomial. But a cubic has a degree of 3. So in this case, this has a degree of 3. This has a degree of 4. It's out. So it's not a cubic. This has a degree of 2. So this is out. So the only thing with a degree of 2, and that's a trinomial, is B. Finally, not finally, but next, we want to take and talk about polynomials in standard form. And a polynomial in standard form lists the order of terms from greatest to least degree. So we add up the powers in each monomial term and then list that from the highest degree to the least degree. The coefficient of the first term is called the leading coefficient. So in this case, we want to make sure it's in standard form and identify the leading coefficient. Look at all the degrees. We see that x to the 6 has the highest degree, so this term should go first. X to the second has the next highest degree, so that term goes second. And finally, 4x has the smallest degree, that goes last. And we want to identify the leading coefficient. The leading coefficient in this case is 3. Let's do the same for the next term. This has a degree of 0, degree of 1, degree of 2, and degree of 3, so that needs to be listed first. 8xy squared plus degree of 2 is next, followed by a degree of 1 from the 5y, and our degree of 0 from the 12. And then we need to list the leading coefficient, so that in this case is 8. And then, once again, let's take a look at all the powers. You notice that 1 and 3 make 4, so 8m n cubed is our leading term. 3 is our next highest degree, followed by 2, and 1, and 0. Leading coefficient, once again, 8. So finally, when we talk about adding and subtracting polynomials, basically we're just going to add and subtract the like terms. And we've identified like terms before. Like terms have matching variables for the monomial and matching powers. So in this case, we want to add these two terms. I have a y squared and a y squared, and I add the coefficients out in front, so that's 12y squared. I have a y and a y. Positive 2, negative 4 is negative 2y, and negative 3 and 2 is a negative 1. And that's written in standard form as well. Let's move over. We see a cube term, but there's no cube term over here, but this has the highest degree, so we list it first. There's a squared term and another squared term. Add those together. We get 5x squared. X to the first term and x to the first term, negative 1 and 4 is 3x. And then finally, constant terms, negative 6. Now, when we have sums and differences written in a linear form, if you will, and there's a negative outside, we have to remember there's a 1 right here, and the intent is to distribute that negative 1 to each term. So I'm going to rewrite this as 6y squared plus 8y to the fourth minus 5y minus 9y to the fourth plus 7y minus 2y squared. And then I'll add everything up. Now, I have a y to the fourth and a y to the fourth. That gives me a negative 1 y to the fourth. Look for y cubes, which there aren't any. y squared. There's another y squared. 6 minus 2 is 4. And then y to the first and y to the first term. I have a total of 15y. Do the same thing for this term. I'll distribute my -1 through. So I have 8y to the fourth plus 3y squared minus 2 minus 6y to the fourth minus 5y cubed minus 9. Match the force. We have 2y to the fourth. I've got a third power here, no third power over here, so I list the third power, keeping it in standard form. So squared, but no squared to the right. So I keep that term as well. And then I look at constant terms, which is -11. Like I said, the math's not too difficult today. Most of it was just definition and recognition. I'd like you to write a lesson summary and do the problems below, and we'll chat tomorrow.